So we'll continue with the chapter 1. So last time we looked at some definitions. We'll continue with some more definitions. So data in general can be broadly classified into two categories. One is called qualitative and other is quantitative. It could be like hair color. You have like different categories, different hair colors, blood group. It could be smartphone brand that you may have. It could be type of car. Basically, like you are dividing data into different categories. Quantitative data could be of two types: discrete or continuous. So discrete data is like you can count. For example, how many customers walked into, let's say, Target between 8 a.m. and 9 a.m. So if somebody is collecting that data, they will get numbers like 0 or 1, 2, 3. So those are like discrete data points because it cannot take a value like 1.1. We cannot say we get a data where 1.1 people walk into Target between 8 and 9. So that will not happen. It can only take values, very specific values like 0, 1, 2. Number of students absent in a class. It could be 0, 1, 2, 3. If a manufacturing company makes some product and they do final inspection, for example, it could be laptop. So they are trying to find if they have any defect. So number of defects again could be 0, 1, 2, and so on. So when you have like data which is like discrete, there are statistical methods that will be more applicable in that area. So that's why we have to know what type of data we are working with. We'll look at some examples in future chapters where we develop statistical models for discrete data. Similarly, data could be continuous. Within two data points, you could have like many values. It's not restricted by, it can only take some specific values like 0, 1, 2. So it could be height of people. So it can be in decimals. It could be speed with which a car is moving on the highway. So again, it can take any value depending on how accurately you can measure. If you consider, let's say, you are driving on a freeway and speed limit is 65 miles per hour. Now, is it possible that we get a reading something like this? 64 miles per hour? It is possible. If we have a tool to measure up to 1 decimal, it depends on like what we are getting with our measurement. Because there is something called reality, and then you have data. And data is never equal to reality. So we are trying to capture reality, but data only approximates reality. We may see that the speed is 64, but that's not reality because exact speed may be very different. So it could be 64.1. If you can measure up to 2 decimals, it could be this. And there is no end to that. Like how many values you can get after decimal, there is no end to that. It totally depends on what measuring instrument we are using. And like for speed, we don't care too much about like that many decimals. But reality is like that. We only get approximation that, okay, speed is 64, but reality could be different. Same thing with any other variable like height, weight, length. So these variables, quantitative variables that can take any value, such variables are called continuous. So between two intervals, theoretically you can have infinite number of values. So we have like a continuous type of variables for which we'll be studying some statistical methods, how to work with that kind of data. So those methods are different compared to how you work with discrete data or qualitative data. We have actually broadly classified these data into two categories, qualitative and quantitative. But nowadays with AI and other things, you may also come across another category of data, unstructured data. So unstructured data, you have things like videos, pictures, images, text data, like what you get on Twitter or X or social media. So all those data belong to unstructured data category. This data that we talk about, where we apply all these methods, is more or less structured data. We have like data in nice rows and columns. But that also is a big category, and there are so many methods people are applying to unstructured data. Now for data collection, we have, earlier we talked about from the population we take a representative sample. So there are different methods of sampling. The most common one is simple random sampling. Now simple random sampling is a random sampling, obviously. And the idea is that every item that can come into the sample has equal chance of getting selected. Each and every item from the population has equal chance of getting selected. So those situations we call simple random sampling. Sometimes practically it may not be feasible. We may not be able to do simple random sampling like in every situation. Let's say there is a foundry where they make some kind of castings for a motorbike. So those castings, that process goes on, they need a lot of sand. So to this foundry, like one of the suppliers will be supplying sand. But that sand has to be of certain quality. It has some properties that it needs to fulfill. So now you have a plant where you have this foundry and a big truck comes full of sand. It's almost impossible to do simple random sampling of the sand. You cannot like randomly pick up sand from that truck. At best what you can do is pick a sample from the top and take it to the lab and then test all the properties. If it looks okay, then accept the entire sand. So it will be very difficult to do simple random sampling. So sometimes it may not be feasible. We just go with what is easily practically available. But this is most common, and within this you have this with replacement and without replacement. So simple random sampling can be with replacement, means you are taking a sample, one item for the sample, and replacing it back. So let's say you have cards, 52 cards, and you take a sample. So one card you take out, you note down what that card was, like that becomes your data point, and then you put it back in the pack of cards. So that is with replacement. So next time, again, you shuffle and then pick up one more card and note down. So when you are taking sample like that, it's with replacement. Other type is without replacement. So whatever sample you are taking, you are not putting it back. So one example of that is some destructive testing. So suppose there is a manufacturing company and they make some items that will go in a car. And it needs to have some level of strength. So what they do is they do destructive testing. They will break it and see how strong it is. So now if you have destroyed it, obviously you cannot put it back. Sometimes we have to do sampling without replacement. So that is one form of sampling, but there are other ways also. Given a situation, we may do stratified random sampling, where you divide the population into different strata or groups and then take samples from each group. So for example, we have, I think, 6 sections of business statistics class running this semester. So in a way, each section is a strata, and somebody wants to take a sample, and it is not possible to get like data from each and every student in 6 sections. So what they can do is they can randomly select, let's say, 5 or 10 students from each section. So stratified sampling means you are dividing it first into different groups and then taking a sample. Another one is called cluster sampling. Now, one difference between cluster and stratified is like they are similar. You still have groups. The only difference is in cluster sampling, if we have 6 sections, we want to take a sample of 3 sections. So instead of doing simple random sampling, we do complete sampling. So if you select 3 sections, then you get data on each and every student. So that's the only difference. In stratified sampling, you are taking still a sample within the strata, but in cluster, you get data on each and every point within each group. So if you have 6 sections, you select like 3 for sample, 3 sections, but then within those 3 sections, you collect all the data. So that's one difference between this and this. Another one is systematic sampling. So you are doing systematic sampling. It could be every nth item. You are selecting every nth item. If it is a manufacturing plant, let's say they are making laptops, and your sampling could be check every 10th for some kind of defect. Or if you want to do a survey of students at UMass Dartmouth about what they think about economy. So you may have a project for a class, and you want to figure out like how the economy will be. So what are people thinking in next maybe few months or next year? How will be the job market? Do you think people will get good jobs when they graduate? So you want to do that kind of survey. So what you could do is you ask every 10th person you meet. You start walking on the campus and you ask every 10th person you see. So that becomes systematic sampling. So you decide beforehand that I'm going to take a sample of maybe 500. It should not be like first 500 people you meet. So you may decide every 10th or every 20th, or maybe somebody every 5 minutes. So if you are using that kind of criteria, it becomes systematic. So you have a system and then you are just following that system. You don't care like who you get for your sample. So that is systematic. Another type of sampling is called convenience sampling. So convenience sampling is like non-random sampling. As the name indicates, it totally depends on your convenience, like how you collect the data. The example that I gave earlier, a truck full of sand. So if somebody is taking sand only from the top for sample, so that's purely based on convenience, because otherwise it will be very difficult, time consuming, expensive. Sometimes we go to like restaurants, for example, they need raw material or things that they can use in food. So they may check rice, for example, that they may take samples in their hand and see if the quality is good or bad. So that is convenience sampling. So something that you can easily do without too much effort. Let's try one of the problems. So local radio station has a fan base of 20,000 listeners. Station wants to know if audience would prefer more music or more talk shows. Asking all 20,000 is almost an impossible task. So it will take time, they have to spend money, so obviously they want to take a sample. The station uses convenience sampling and surveys the first 200 people they meet at one of the station's music concert events. So they have organized a music concert and they ask 200 people. So 24 out of that prefer more talk shows and 176, so they mention that they like more of music. Do you think that this sample is representative of the entire 20,000 population? Or do you think like they could have done better? Yeah.
And it makes it bigger because it's like not enough people really to like get a good like understanding of like the majority of people. It's just like a small fraction of people, and also that one radio station, so it's just like that one area.
So you feel 200 is a very small sample compared to 20,000. Yeah. 200 is like 1%. So one issue you are saying is sample is small. Other is?
Oh, it's also like not very either. It's that one radio station, not multiple. So it's like it's only for like one like part like of the audience, not multiple.
Okay, so they only went to one location where there is a concert, and also that is a music concert, right?
Yeah.
So there could be some bias because of that, right?
Yeah.
Because obviously music lovers will go to music concert. So you should not be surprised that more people out of 200, 176 prefer music. But remember, that's only 200, as you correctly pointed out. There are still, how much is 20,000 minus 200? So that is like 19,800. 19,800 we don't know. We are trying to make a projection for those people what they would like, but then we go to only like a music concert. So it's a very, very biased kind of. It is convenient sampling, but it is very biased. You should be surprised that out of 200 people, there are still 24 people who love talk shows at a music concert. So definitely there is a problem here. And whatever data we get will not be representative of the entire population. And then you make decisions based on that will be obviously misleading. So we talked about data and different types and sampling. Let's talk about levels of measurement. So levels of measurement basically indicates what kind of data you have. One is called nominal. You may have nominal type of data, or you may have ordinal, or interval, or ratio. So these are like 4 names we use for different types of data. It's important to know what kind of data we are dealing with, because for every kind of data you have specialized statistical methods. It's not that you have one method that you can apply to every data that you get. There is a saying in English like, if the only tool you have is hammer, then every problem looks like a nail. So we need to have like different tools available to us so that we can apply different tools in different situations. We don't have to go with just one tool and try to solve every problem. Nominal data is basically the simplest form of data. Name of people, name of things is an example of nominal data. So it's basically a categorical data or qualitative data, which can be put in different categories sometimes, but it's just a name. It's just a name. It could be name of buildings, name of classrooms. For example, this is like CCB 147. So that's a nominal data. It can be text, a student's name, it can be text. A student also may be identified using a number, student IDs. It is possible that there may be more than one person in that university that has exactly same name. So they use student IDs so that each person can be identified uniquely. So nominal data can be number, it can be text, but it's a very limited kind of data. You cannot do too much with this data in terms of statistical analysis. There are not many statistical methods available to work with nominal data. So the information contained in the data is very limited. You cannot extract too much out of this kind of data. Slightly higher level of data is ordinal data. So ordinal data, as the name suggests, there is some order to this kind of data. So data points that can be put in some order. Like students may be freshman, sophomore, junior, or senior. So there is an order to that. Similarly, coffee cups. If you buy coffee, you may have a small, medium, large. So there is an order to that. So that data is ordinal data. So whenever you can put data in an order, it is this form of data. Now slightly higher level of data with slightly more information is interval data, where, as the name indicates, interval between two data points makes sense. So for example, temperature. So let's say yesterday it was 61 degrees and today it is 58, and then you take a difference, so you know that it is colder by 3 degrees. So the difference between the two numbers makes sense for temperature, so it is interval kind of data. And then finally you have a type of data which is called ratio data, where ratio of two numbers makes sense. So for example, profits for a business. So if a company made, let's say, $50 million last year, and this year they are making $100 million in profits, then we can divide these two, take a ratio, and say that for that company, profits have grown by 2 times or 100%. So ratio in this case makes sense. Another example could be age. If you have a father who is 40 and son who is, let's say, 20, so 40 divided by 20 again is 2. So that makes sense, like father is 2 times older than son. So that is ratio kind of data, where ratio of two numbers makes sense. So one thing you will notice is, as you go down from nominal to ordinal, ordinal to interval, interval to ratio, so each one will have properties of previous ones. So ratio still has property of interval. You can still take a difference, and 100 minus 50 still makes sense. But because the ratio here is more important, like it has more information and ratio also makes sense, so profit will not be treated as interval data, but it will be treated as ratio data, because ratio also makes sense. So each level has properties of the previous ones, like ratio still has a name. So profit is a name for some metric that company is using, profits. It could be sales, revenues, expenses. Age is a name. So it has a name, and then you have some data. So each level has properties of all the previous ones. So a good thing because of that is, by the time you reach here, the information contained in the data is like quite high. So information contained, you can do so much with the ratio data compared to the previous ones. Like nominal data, very few statistical methods may apply. You may be able to create a bar plot of, okay, last name starting with A, B, C, something like that. Not much you can do. You cannot add, divide, but ratio you can do almost anything. So because of that, if for anything you are working with data, when information contained in the data is more, even small samples will be good enough because they will tell you a good story. You'll be able to tell a good story with smaller data sets. So ratio data, I would say, is more useful compared to others. But in some situations, you have no option, like name, for example. So that will remain nominal data, whatever you do. So with that, we complete chapter number 1, sampling and data, where we were broadly going into various definitions of what is statistics, what is data, different types of data, different types of sampling, population versus samples. So all those things. We'll move on to chapter number 2.